So today we will discuss about differential equations, and we have selected some important questions of Cambridge A-level math exam. We will solve the previous exams questions. So before starting our class, I would like to discuss about some important equations of differential calculus. So we will discuss some basic information now. Calculus is two kinds. First is calculus is differential calculus. Differential calculus. And another is integral calculus. Integral calculus. So today I would like to discuss about our first topic is differential calculus. And I have chosen some important previous questions and I will solve those questions consecutively. Differential calculus. In differential calculus, we use this operator d dx. It is an important operator of differential calculus. D dx of x. If we differentiate this function x, we will get output 1. Similarly, if we differentiate this function d dx of x to the power n function, we will get n into x to the power n minus 1. D dx of ln x. If we differentiate ln x function, we will get 1x, 1 by x. D dx of ax function, we will get ax ln a. Number 5 is d dx of sin x equal to cos x. If we differentiate sin x function, we will get cos x function. Number 6 is d dx of cos x function, we will get minus sin x function. D dx of tan x equal to sec square x, and d dx of cot x equal to, we will get minus cosec square x. If we take an example, right, x cube, if we differentiate this function, what we will get? We will get 3x square. We will get 3x square. This is the answer of this function. So we have to always remember that differentiation means the rate of change of y variable with respect to x. Okay, so differentiation means the rate of change of y variable with respect to x. It determines the changes of y variable with respect to x variable. So our first question is, here we can see there is a function y equal 9t square plus 40. So we have to differentiate these equations. So at first we will take the operator d dt, because it is the operator of differentiation, and we will differentiate the y function. So we will get d dt, a differential operator, and here we will get the y function, that is 9t square plus 40. So here The differential operator will act two times. First, d dt 9t square plus, and differential operator will act second time, d dt 4t. Okay, so previously we have discussed about some important formulas of differentiation. So here we can see that d dt, the differential operator, it is acting on 90 square function. So here we can see that there is a number 9. So it will be written in first of differential operator, and the differential operator will act on t square. We have discussed about that if our differential operator is d dx and our function is x, the result will be 1, right? And if our differential operator is x and our function is a different kind of variable, like you can say y, or maybe m, or maybe n. Here we can see that our functions, in functions the operator is different, so the result will be 0, because this operator only act when when our functions operator is same. Okay, so we can see that our differential operator, its variable is x and the functions variable is also x, the same variable. So then a differential operator can act and can give us the result. If the differential operator and the functions operator are different, the result will be 0. Okay, and here we can see that there is a number 4, so it will come outside, and the differential operator will only act on the variable d dx of x to the power n equal to n into x to the power n minus 1. So this formula will be applied here. This formula will be applied here. So the formula will be n into x to the power n minus 1. So the result will be 1. So 9 times 2, that means 18, and 2 minus 1, that's mean 1. So 18t plus 4. This is the result of this function. So we have solved our first math, and I would like to go towards second math. Here, here is a function s equal to 4 e to the power 2x. So now we will solve this math. So let's start our solution. Okay, so we will take our operator. So we have to take differential operator d dx, and we will apply this operator on s function. So we will write s function here, and we will now write the full form of the s function, 4 e to the power 2x. Okay, so we have to know that there is important uh, formula of differentiation, like if we apply d dx operator on e to the power x function, we'll get e to the power x. Okay, and if we act d dx function on e to the power mx function, the result will be m into e to the power mx. Okay, so we have to remember these two important formula. Okay, okay, so now we can see that there is a number, so it will come outside, 4 into d dx of e to the power 2x, like, right? So now you can see that this function and this function is quite similar. Here we can see there is a mx, so we will get the output m into a to the power mx. And here here we can see there is a 2, so we can compare as m into e to the power mx. So this is the result of our second method. 4 times 2, that means 8 e to the power 2x. So this is the result of our uh, second method. Okay, now we will solve our these questions. 1 divided y minus 1 into dy dx equals 6x square. If we rearrange this math, we can write dy dx equal to 6x square into y minus 1. And if we multiply 6x square into y, we will get 6x square y minus 6x square. Now we will apply differential formula on this function. Okay, so we will get dy dx equal to dy dx of 6x square y minus dy dx of 6x square. We will get the output of dy dx equal to, the 6 will come outside and the operator will act on this portion x square y minus, and here the 6 will come outside again, d dx of x square function. There is two variable, one is x and another is y. So here the uv formula will be applied here. So we will apply uv formula, x square d dx of y function plus y d dx of x square minus, here we will get 6 into 2 into x, because here the x to the power n formula is applied, n into x to the power n minus 1. Okay, it is minus 1. Okay, so what we will get x square into, here you can see there is a y operator, so we will get simply dy dx, sorry, it is multiplication plus, and here we will get y into 2x, like x to the power n formula, and here we will get 12, 6 times 2, that means 12x. Okay, and again the 6 will be multiplied here, 6 x square dy dx plus 12xy minus 12x. So this is the answer of our these functions, these questions. Okay, now we will solve this math. Before solving this math, we have to rearrange this equation. We will write dx dt equal minus 9t square plus 4. Okay, and we will now apply differential operator of this portion. Our operator is t, so the differential operator will be applied here, d dt of minus 9t square plus d dt of 4. We know that the minus 9 is a number, so it will come outside minus 9, and differential operator d dt will apply it on t square, plus we know that if we differentiate any any fixed value or any fixed number, the result will be 0. Okay, if we differentiate any constant value, the result will be 0, minus 9, and here the x to the power n formula will be applied, so the result will be n into x to the power n minus 1, or 2 into t to the power 2 minus 1. Minus 9 times 2, that means minus 18 t to the power 2 minus 1 equal to minus 18t. So this is the answer of our these questions. Equal minus 4 equal 2 to the power 2e to the power x. So our next question is dv dx minus 4 equal 2 into e to the power x. So before solving this math, we have to rearrange this function. We will write dv dx on left side, and in right side we will write 2 e to the power x plus minus, and here will be plus 4. Now we will apply the differential operator on right side. dv divided dx equal to d dx of 2 e to the power x plus d dx of 4. We know that if we get any number, the number will come outside. dv dx equal to, here we will get 2, and the differential operator will act on e to the power x plus the differential operator will act on the constant number, so the result will be 0, because constant number cannot be changed, so the result will be 0. And here we will get 2. We know that if we differentiate any e to the power x by exponential function, the result remains same, so the result will be e to the power x. So the final result will be 2 into e to the power x. This is our final result. Our new another new math is uh, d dt, the differential operator, and the function is s function equal to 6t square minus 2t plus 5. So in this function, the differential operator d dt of s function, the differential operator dt will be applied here. So d dt of 6t square minus differential operator d dt of 2t plus t dt of 5. Here we can see there is a number, that is a constant number, so it will come outside. 6 d dt of t square minus, and here we can see there is another number, it will come outside again. 2 d dt function will act on t function plus, here you can see there is a constant number, right? There is a constant number. If we differentiate any constant number, the result will be 0, because constant number cannot be changed, so the result will be 0. Here we can see there the differential operator and the variable is same, so you can see t square, we can relate this function like x to the power n function, d dx of x to the power n function. We can relate this function like this, so the result will be n into x to the power n minus 1. So the result will be 6 into 2 into t to the power 2 minus 1 minus, and here the result will be, if we relate this function like d dx of x function, the result will be 1. So this function and this function is similar, so the result will be 1. So we can write 2 into 1 plus 0. 2 times 6 times 2, that means 12, and 2 minus 1, that means 1, 12t, minus here we can get 2 into 1, that means minus 2. So this is the final result of this function, x square into y minus 2. If we simplify this question, we will get d dx equal to x square y minus 2x square. Okay, now we will apply our differential operator here. So we will get d dx of x square y minus d dx of 2x squared. Okay, here uv formula will be applied. I am writing the uv formula so that you can understand. U d dx of v plus v d dx of u. So this formula will be applied here. Okay, so we will apply this formula, x square into d dx of y plus y into d dx of x square minus, here we can see there is a constant number, so it will come outside 2, and d dx of x square, okay, into dy dx plus y into, here you can see there is a x to the power n like formula, so the formula will be x to the power n formula, so the result will be n into x to the power n minus 1 minus, here it is a similar, so the result will be n into x to the power n minus 1, 2 yx minus 2 times 2, that means 4x, and left side dy dx. If we rearrange dy dx minus x square dy dx equal to 2yx minus 4x dy dx, so I can get 1 minus x square equal to 2yx minus 4x, and again I can write dy dx equal to, if we take 2 common, I can write 2x common, I can write y minus 1 divided 1 minus x square. So this is the ultimate result of our last question. So this is the way of solving, and I have solved around 5 to 6 maths, and because math is very easy. And thank you so much for uh, for watching this video.